Hey, Year 11. This is a quick video going through 6H and 6I for those that missed today's session. So we're going to be going through the volume of cylinders and spheres first. Now, a cylinder is just like a prism where the cross section is a circle. Now, if we think back to what the volume of a prism is, well, the volume is just area times height, okay, of any prism. But now my area of my end is a circle, so pi r squared. So this is my rule for the volume of a cylinder, just pi times r squared, which is our circle, and then we times pi r height. So we do a quick example over here. We have the volume of this shape here. We want to find the area of the top, which is pi times radius squared. Now our radius is 8, since our diameter is 16. Pi r squared times by my height. Okay, put that in our calculator. And we have a volume of 2,412. And we'll round to one decimal place, 0.7 millimeters cubed, because we're talking about volume here. Okay, if you need to pause and get that example down, do that. We're going to move on to spheres. So a sphere has a pretty interesting volume rule. It's 4/3 pi r cubed. It's our first one with a pi r cubed in it. And we've got this fraction, 4/3 out the front. So then if I have half a sphere, we would have a hemisphere, which is half of this, which we could simplify these fractions down to, instead of 4/3, we just have 2/3 pi r cubed. So if you compare these ones here, you can see the only difference is this has got 4/3, and because we've got half of that, we've only got 2/3. And then the rest is the same. Okay? At this point, I'm going to do another example, which sort of puts these together. So we imagine that we have a can full of tennis balls. Okay? One. Let's just make this a bit higher. One, so I can draw circles properly. There we go. There's my can of slightly squished up tennis balls. But we pretend that all those tennis balls are nice and even. And they all have a diameter of 12 centimeters, every tennis ball. And now my question is, how much air is in the can? So we need to figure out how much air is around these tennis balls inside the can. Okay? And we do that by first figuring out the volume of our cylinder. We'll say volume of cylinder. Okay? Now, we know that that is pi r squared h. So we need pi times my radius. Now my radius of this is half of 12, so it's 6 squared. Now, what's my height of this cylinder? We know that this is 12 this way, and all the tennis balls are 12. So if we presume that these tennis balls touch both the bottom of the can and the top of the can, we're going to have a height of 12 times 3, or 36. And that is what we're going to put into our calculator to get an answer of 4,071.5. Now that's the volume of our cylinder. Now we need to take away the volume of our 3 spheres. Now, one sphere, or one ball, has a volume of 4 over 3 pi r cubed. Our radius is not 12, it's 6 for one tennis ball, but we have 3 tennis balls. So we times by 3 there. And I'm just putting this in my calculator. Whoop. And we get 2,114.3 centimeters. Now, to figure out the volume of the air, we need to do the volume of the cylinder minus the volume of our spheres. Okay, so we're going to do our 4,071.5 minus 2,714.3, and we get our final answer of 1,357.1. We'll round that up to 0.2, which is cubed. By the way, these were both cubed as well. So if you need to pause that to get that example down, that was a level 3 example. If you can do that, we should be right with 6H, volume of a cylinder and a volume of a sphere. Okay, let's move on to the volume of pyramids and cones. Now, a pyramid is the same as a cylinder, except it takes up a third of the room. So if you can see my camera down here, not too well, you can see that's a sphere, a cylinder there. No, sorry, that's a prism, a square-based prism. And if I have the prism, but it goes to a point, that becomes a pyramid. That shape there is going to take up a third of the volume that the prism takes up. So we have the volume of a prism here, and we just stick a third in the front. Okay, there we've got a volume of our pyramid. So whatever the area is here, we need to figure that out first, whether it's a square or a rectangle or even a circle. We then times it by the height, just like we normally would for a prism. But then we've got this third out the front. Okay? So if you want to write that one down and draw a picture, you can pause. Now, if the base is a circle, we get this area becomes pi r squared. Okay? That's our area, and we have pi r squared. So that becomes our volume of a cone, which would be a third of a cylinder. Okay, let's do an example of each of those. So once you've drawn that, we can do the volume of this shape by just doing a third times my area of the base times by my height. So we have a third. The area is 5 times 3. And then my height, 5 times 4. And then my height is 6. So we put that all together in our calculator, and we get 40 centimeters cubed. If I've got a cone, let's do this one down here. We again have 4 times my area, third times my area times my height. Which is a third times pi times r squared, which is 10, times my height, which is 26. I'm going to need a calculator for that one. 722.7 meters cubed. If you want to get that down, you can pause the video here. And now we move on to a trickier example. Here we've got this cone that has the top chopped off it. Okay? So if we want to figure out the height of this shape here, we first consider the whole cone, and then we're going to take away the top part. So we call the big cone volume 1. Volume 1 is just 1/3 times pi times my radius, which here is 15, half of 30, squared, times my height, all the way up, which is 40. Okay, put that one in our calculator. We get 9,424.8. That's the big cone. Now, if we want to get rid of the top part, we need to figure out the volume of this little one here. Okay? Now, same rule, 1/3 times pi times. Now, since we're halfway up, this whole length across here is 15. So halfway across, I should probably draw that arrow up a little bit up here. Is 7.5. Okay, and then our height is 20. So we put that one in our calculator. We get 1,178.1 centimeters cubed. If I want to find the volume of our shape, this shape here, that volume is the big cylinder minus the little cylinder. So we can put that in our calculator. Well, I should probably write what it is. 9424.8 minus 1178.1. And we get our final answer, which is 8,246.7 centimeters cubed. And there you go. So that was a level 3 question for 6i. You now have enough to get through all of 6h and 6i by yourself. If you have any more questions, feel free to email. All right. See you later. Good luck.